This will be for the con exercise, number of solutions of quadratic equations. So just some notes before we begin. If you have a quadratic equation in the form of ax squared plus bx plus c equals 0, and you can't factor it, or even if you can factor it, you can use the quadratic formula to solve for x. Now this part of the quadratic formula that's under the square root, b squared minus 4ac, that is called the discriminant. Okay, so b squared minus 4ac is the discriminant, and that determines how many roots and the type of roots you will get when you use this formula. All right, so let's take a look at the three cases. Case number 1, b squared minus 4ac is positive. Okay, in other words, the part that's under the square root, this part right here, turns out to be positive. So you're going to get plus or minus the square root of a positive, and the square root of a positive is still positive. So if you do plus and minus a positive number, you are going to get two real roots. All right, those roots are going to be real numbers. And on the graph, it basically looks like this. Okay, the parabola will cross the x-axis twice. Okay, so those 2 points on the x-axis, this is the x-axis right here, those 2 points are called the roots or the zeros. All right, so in this case, you will have two x-intercepts when the discriminant is positive. And that is what the graph will look like. Now, the second case is when b squared minus 4ac is 0. Okay, so if you get a 0 under the square root of 0 is just 0. You're going to get plus or minus 0, and that returns the same number. Okay, if you did 5 minus 0 and you did 5 plus 0, you would still get 5 in each case. So plus or minus 0 just returns the same number. It doesn't change anything. So in that case, you will just get one real root, okay? And in other words, on the graph, you will have one x-intercept. And on the graph itself, this is what it would look like. The parabola would just intercept the x-axis at one point only. Okay, and that one point on the x-axis, that is the root or the 0. All right, so again, if b squared minus 4ac is 0, that's one real root and one x-intercept. And for case number 1, we said if it's positive, that's two real roots and two x-intercepts. Now the third and final case, b squared minus 4ac is negative. Okay, so in other words, the part under the square root is negative. This is going to be an imaginary number, not a real number. So you're going to get plus and minus an imaginary number. All right, so in other words, you're going to get two imaginary roots. They're going to be in the form of a plus bi and a minus bi. All right, so that is the case when the discriminant under the square root is negative. All right, you get two imaginary roots. And what that means is the graph never intercepts the x-axis. Okay, it never reaches the x-axis, and you basically have no x-intercepts. All right, so this is what the graph would look like. The parabola never reaches it. It could also be upside down, of course. All right, but the point is it doesn't have any x-intercepts. It doesn't have any real roots. It just has two imaginary roots. All right, on to the problems. What is the value of the discriminant of f? All right, we know the discriminant, we said it a minute ago, is going to be b squared minus 4ac. So this function f is in the form of ax squared plus bx plus c. Okay, pretty convenient. So A is positive 6, B is positive 10, and C is negative 1. Okay, make sure you maintain the plus minus signs. So B squared is going to be 10 squared minus 4 times A, which is 6, times C, which is negative 1. All right, you can use the calculator, but this one's easy. 10 squared is 100. Negative 4 times 6 is negative 24. Times negative 1 is positive 24. And, of course, 100 plus 24 gives us 124. So you click in the box and type 124. How many distinct real number zeros does F have? Well, we said it a minute ago in the notes. If you have negative B, plus or minus, radical, and the discriminant is positive, all over 2A, you're only worried about this part here. If the discriminant is positive, that is 2 real roots. Okay, because it's plus or minus a positive number. You're going to get 2 real numbers out of that. Real roots, real zeros, same thing. So you just enter a 2 in the box. This was case number 1 in the notes. Is discriminant of F positive, 0, or negative? Let's take a look. All right, this is pretty easy. If you look at the graph here, we can see right on the graph, this parabola, here's our x-axis right here. And we have 1, 2 x-intercepts. All right, 2 x-intercepts. And we said in the notes, if it has 2 x-intercepts, that means it has 2 real roots. All right, and that means it's going to be negative B plus or minus the square root of a positive all over 2A. So the discriminant, which is the part that's under the square root, the discriminant is positive, okay, because it has 2 x-intercepts or 2 real roots. Again, that was case number 1. So positive, 0, or negative, it's multiple choice. Positive, that's for your B squared minus 4AC. All right, repeat of the first problem. What's the value of the discriminant? We're looking at B squared minus 4AC. This is set up nicely in the form of AX squared plus BX plus C. Perfect. All right, B squared is 8 squared minus 4 times A, which is negative 7, times C, which is positive 2. On the calculator, 8 squared minus 4 times negative 7 times 2. I get a solid 120. How many x-intercepts? Well, when this is positive, we said it before, that is 2 x-intercepts. Is the discriminant of G positive, 0, or negative? Let's see. Okay, here's the function G. Here is the x-axis right here. Does the graph have any x-intercepts? No, it does not. It never reaches the x-axis. That's no x-intercepts. All right. So what does that mean? 2 imaginary roots. And what does that mean? That means you have negative B plus or minus the square root of a negative all over 2a. All right, in order to get imaginary roots, the square root part or the discriminant has to be negative. All right, and you'll get no x-intercepts. So what did they ask? For the discriminant, positive, 0, or negative. Well, clearly it's negative. So if we go to the choices, answer C, negative.